So today and in our next video, we'll be reviewing the metric measurements that you've learned over the years. And I wanted to start off with the most basic ones that you've really gotten a lot of experience with that we'll be doing some labs with in class. The very first metric measurement is talking about length. And this is probably the easiest one for us to think of, because as long as we can remember, we've been talking about things in terms of distance and how far objects are away from us. So what you're going to do is work your way across this table and fill in the blocks as you see them written up here on the screen. The definition of length is the distance between 2 points. And the most common units that we'll see used in the metric system, especially in science class, would be millimeters, centimeters, meters, and kilometers. And so we talked about before how the prefix that you add on to the base unit tells us how small that unit would be. So the millimeter would be the smallest, and the millis stands for 1,000th of a unit. The kilometer would be the largest. That stands for 1,000 total units. Centi stands for 100th, and if you want to think about there being 100 cents in one whole dollar, you can kind of connect those two meanings there. We don't really need a formula to find the length of an object, and the equipment that we typically use in class would be a meter stick or a metric ruler. And so this example just shows out different measurements that you might see on a metric ruler in class. And so, for example, A is between the 0 and the 1. So right here it's just past the halfway point, so A would be 0.6 of a centimeter. I'm not going to go through every single measurement, but we can just point out another one, like F is here between the 6 and the 7, and it's just past the halfway point, and so our answer for F would be 6.7 centimeters. So you should notice that on this ruler there are 10 spaces between each whole number. What's the nice thing about the metric system is that it's based on powers of 10. So if any of you are in ag science, you can tell Mr. Eanes that the metric system is so much easier because you can easily convert it to decimals, where the rulers we use here in America that he's teaching you are a little bit more difficult. So try not to get them confused. One other thing I want to point out is that over in the rest of the world, really, they use the metric system because it's so easily converted from one type of unit to another, since it's based on powers of 10. So if you ever travel outside of the country, this is actually what the speed limit sign would look like versus the rectangle that we usually see here in America. And so the sign is actually going to be shaped like a circle, and it's going to have a red circle at the very edge. And the weird thing is, if you're just riding along with someone else driving you and you happen to see a sign that says 120, like the one that I'm circling here, I've actually seen this sign before outside of the country. I went to France once and I saw this sign and I thought, oh my gosh, those people are going so fast. But then I realized that in France, they use kilometers per hour, so to convert that number, that would be about the same as us going 70 miles per hour here on the expressway from Amherst to Lynchburg. Our next row is mass. Definition of mass, just to review that, is that it measures the amount of matter contained in an object, so how much stuff makes it up. The main units we'll use in the class are grams and kilograms. So grams are going to measure smaller objects, kilograms would measure larger objects. Again, there's no formula that we need to know. Main equipment we'll use is the triple beam balance. We also should get some experience in class this year of using a digital scale, which is more common these days. So when you're using a triple beam balance, first you have to move these different masses on the beams until you get the balance to line up with the 0 at the end. So once you get these measures in place, you'll see what this little arrow is pointing at, and you'll add up all of the digits. So here on this example, we've got 300, 40, and 7. So when you add all those numbers up, your object would have a mass of 347. Usually this will be in grams. The last row that you're completing in your notes this evening is about volume. Now, mass and volume are easily confused. Mass is how much matter is in the object, so how much stuff it is. Volume measures how much space it takes up, so in 3 dimensions, how much room it takes up in the air. So based on what we're measuring, we'll have different units. For liquid, we'll see milliliters for smaller amounts and liters for larger amounts. and we'll also see centimeters cubed most often for a solid. The nice thing that we have pointed out before is that a milliliter is the same thing as a centimeter cubed. Now, if we wanted to find the volume of a solid, and this is usually for just a regular cube, you would use the formula length times width times height. There are other formulas for different measurements, and so we'll talk about those as needed. Equipment that you would see used for volume would be a graduated cylinder or a beaker for liquid, and a metric ruler would be used for those dimensions in a solid. One thing that's very important for us when we are making measurements using a graduated cylinder is that you should notice that liquid is typically going to cling to the sides of the graduated cylinder, and it will kind of settle in the middle. So what you want to do when you're making your measurement is look at this thing called the meniscus. That's basically the center where the liquid has all settled and it's not clinging to the side to give you a false reading. So for any time you're using graduated cylinder, you want to look at the bottom there. So for this example, we need to look at the meniscus, which is set down here. This arrow didn't really work out very well. And so we're just past the halfway point, which would be 55, and one more past 55 gives us 56 milliliters. That is it for the notes so far. We'll fill in the other half of this sheet when we come back for our next video. I will see you in class. You have a great day.